Okay, and this is another installment in my Sentential Logic series. I've done a few videos, few longer videos where I've done multiple problems of sentential logic derivations. Basically, we're doing proofs, and we're proving derivability claims, stuff like that. And we're just showing you how to use those 11 rules to, if it says that you need to get something, that you can get it through having a set of assumptions. However, today in this video we're going to be doing what is called a theorem. A theorem in sentential derivations or proofs is a proof where you have to derive something and yet you have no assumptions at all. You have nothing to work with, so you have to start from scratch, basically. That's basically what this is. I have gotten 4 problems together, worked them out, and made sure that they were good for this, except for the last problem is a 40-line derivation, so that's going to be a little bit difficult to get on this board, but and that one's kind of harder, but most of these are pretty simple if you know your 11 rules and you know, basically I would recommend trying the derivations where you have assumptions, where sometimes you're given 1, 2, 3 or more assumptions that you have to work with, so you can get what you're asked to find and get with your 11 rules. But a theorem is when you have no assumptions and you're asked to derive something. So in this first problem, we're going to derive the following: A horseshoe bracket B horseshoe A ampersand B. So we have to derive that, but we have no assumptions. So basically what we do, sometimes people just don't do anything and they just start from scratch by making assumptions. But what I do is go 1, and I'll go like this, and go like that, to say that we have no assumptions to work with. Hopefully you can see this okay. So in a theorem, I think the easiest thing to do is when your dominant operator is a horseshoe, when it's a conditional, because that's pretty easy to do. So the first thing we're going to do is assume A for horseshoe induction, and obviously we're going to try and get B horseshoe A ampersand B. That's the first thing we're going to do. We're going to assume the antecedent and prove the consequent, even though we have no assumptions to work with. We just have to find it all ourselves and assume it, and we have to assume it ourselves and get it. So since we have no B, we have to also assume B. Since we have this, we need to assume this to try to get that, and let's assume B and try to get that. This is the easiest problem of the 4 that I picked. Assume for horseshoe induction, we're going to derive A ampersand B. And we can easily put that together because we have A and B. That's from lines 2 and 3, ampersand intro. Thus we got that. Thus we can exit out of that subderivation with B horseshoe A ampersand B. So we have A and B already there for us, therefore we can just put them together by the law, or by the rule of ampersand introduction. Thus in this we got what we were after, therefore we can exit out of this one with A horseshoe B horseshoe A ampersand B. That's pretty simple, right? I mean, you're just assuming to get what you're after. Okay, that was the simplest one, and this gets harder, trust me. I'm sorry, I'm very sorry that I picked a 40-line problem. That's probably Bad judgment on my part for this. Okay, number 2, we're going to have to derive bracket A horseshoe B horseshoe A horseshoe A. Now, these problems I've taken from a book called The Logic Book, and that's basically what I've used for this whole logic series I've been doing. I've been taking those problems and doing them myself outside of the video to make sure that they're good for a video like this and that they'll, you know, I guess show what I'm wanting them to show. So again, given this is a theorem, we're proving that this is a theorem. And if we can't prove that without having assumptions, it's not a theorem. And again, we have no assumptions. So what is our dominant operator here? A horseshoe, conditional. So naturally, what we're going to do is the following again: A horseshoe B horseshoe A, assuming for horseshoe intro to get A. And since we're after A, we don't have A just sitting for us. So another nice little tactic when we're doing theorems is that since we have nothing to work with, we have to start from scratch. A good thing to do is to assume the opposite of what we want. So we want A, we assume tilde A. We're assuming this for tilde elimination, and we want to derive a contradiction. And so basically what we want is to find a contradiction within here. So we don't really have any contradictions just sitting here for us, so we have to assume something further. And we're going to assume A. Assuming A for horseshoe intro. And we're going to try to derive B out of it. And thus we don't have B just sitting around either, so we have to assume, again, something further. Theorems usually involve multiple sub-derivations. And we're assuming B for tilde elimination, and we're again trying to get a contradiction. Hopefully you can see this okay. I hope I'm not totally just writing stuff that you are unable to see. And now we have a contradiction just laying around. We have tilde A here, we have A there. Therefore we can go A from line 4, reiteration, and again tilde A from line 3, reiteration. Boom, we got our contradiction. Therefore we can exit out of this with B, and that's from lines 5 through 7, tilde elimination. And since we assumed A to try to get B, because this was a horseshoe introduction, we got B, therefore we can exit out of that with A horseshoe B, and that's from lines 4 through 8, horseshoe intro. So since we have A horseshoe B, basically we have this up here, this A horseshoe B horseshoe A, and thus we have that, and we have the antecedent, thus we have the consequent A, and that's from lines 2 and 9, horseshoe elimination, because we have the antecedent there before we have the consequent. And boom, we have a contradiction sitting around for us to use. So we're going to again reiterate tilde A from line 3. Boom, contradiction. I should have done this too. So we got our contradiction, tilde A and A. Therefore, we can exit out of this with A. And that's from lines 3 through 11 till the elimination. And pretty much we have what we want. We assumed A horseshoe, B horseshoe, A to get A. We got A, therefore we can X out of the whole thing with and that's from lines 2 through 12. See how that happened? We had to do a few sub derivations because in these theorems we don't have just sitting around what we want, so we have to assume it to try and get it. So naturally, we assume the antecedent to get the consequent, and we assumed tilde A to try and get that consequent, and then we had to assume A to get A horseshoe B, therefore we would have A, and thus we would have having A means we have a contradiction, and thus we got it. So if you think I'm messing this up, or well, I'm not messing it up, but if you think I'm explaining it too fast, or you need more walkthrough or something like that, then please do let me know, and I can do a follow-up video explaining something, or I can do another video in theorems, or whatever you like. See, you can pause it if you want to look at it more, and erase. 2 more problems to go, except for one of those problems is a giant. Oh, actually I have 5 problems. Okay. So number 3, we're going to derive A horseshoe B wedge B horseshoe A. We got a wedge, so there's something else that is going to be interesting. Again, we have no assumptions. So naturally, we don't have any of this around for us. So what are we going to do? To get this, the best course of action, since we don't have either of them to make a wedge induction with, is to do this. Assume the opposite and find a contradiction inside of here somewhere, and thus we'll find it. So this is a little assume the opposite and find a contradiction inside of here somewhere, and thus we'll find it. So this is a little bit complicated, but it'll be all right. First off, we're going to assume B for tilde induction. Again, we're going to derive a contradiction. And why do we want to assume B to get tilde B? We want to do that so that we can have tilde B waiting around to get a contradiction with later. This is this 18-line derivation. And we're going to further have to assume A for horseshoe induction and try to get B. have B already, and it's sitting around. Line 3, reiteration. Thus we can exit out of that real quick with A horseshoe B, lines 4 through 5, horseshoe intro. And by the stupidest rule ever, horseshoe introduction, we can do the following. Or not horseshoe introduction, but wedge introduction. We can go like this. Because basically, if you have a disjunct, if you have one thing, you can slap anything on it via that wedge. The whole disjunction rule is weird, because if you have a disjunct, you can make anything you want the other disjunct. And we have a contradiction already, because from line 2, reiteration. Boom, we got a contradiction. Therefore, we can exit out of that with tilde B from lines 3 through 8, tilde intro. And thus we have that sitting around for us. Number 10. We're going to assume B. We're going to assume B for a horseshoe introduction, because we want to get B horseshoe A so that we can basically slap the whole thing on again, slap the other disjunct on, and get a contradiction inside of here, inside of this big one. Therefore, we can exit out of this with that. Therefore, we're going to assume B for horseshoe intro. We're going to try to derive A. We'll have A sitting around, so we're going to assume tilde A for tilde elimination, try to derive a contradiction. And we have a contradiction sitting around for us, which is so we have B from line 10, reiteration, and line 13 we have tilde B from line 9, reiteration. Boom, we got a contradiction. Therefore, we can exit out of this with A, which is 11 through 13, tilde elimination. Well, we got it. And we can exit out of this whole thing with B horseshoe A. That's from lines 10 through 14, horseshoe intro. And notice up here we have B horseshoe A, therefore we can slap A horseshoe B on it because of the stupidest rule ever. And we have a contradiction now. Line 2, reiteration. Boom. Therefore, we can exit out of this with A horseshoe B wedge B horseshoe A. And that's from lines 2 through 17, tilde elimination. Now that's a longer, more complicated problem. But if you understand what you're doing, then it's pretty simple. And I think I'm going to skip the other one I had prepared. Therefore, we can so we can jump into the other one, because the 40 line one is what we're going to do next. Because that's going to take a sec. And pause if you want to. No erase. And erase. Get ready for the giant horror of a derivation. And the reason this is so long because we're trying to get a sentence that has the biconditional as its dominant operator. So what we want is tilde a triple bar b triple bar a triple bar tilde b. We want that, so I'm going to have to go part of it here, part of it here, because it's huge. And again, we have no assumptions to work with. So in a biconditional, what we're going to have to do, we're going to have to assume this and get that, and then assume this and get that. One of those operations is very easy, the other one is very difficult. Well, not difficult, just long. Naturally, we're going to do the difficult one first. Normally, I don't like to do that, but we're going to do the difficult one first because this is very long and difficult and strenuous. We're going to assume tilde a triple bar b first and try to get, we're assuming this for bar intro, to try to get a triple bar tilde b. And this is just sub-derivations galore right now. And inside of that, we're going to have to assume a, again, for the bar intro, to try to get tilde b, of course. And we don't have tilde b just sitting around, so we're going to have to do another thing. We're going to have to assume b for tilde intro to derive a contradiction. And what we're going to have to do is try and get a triple bar b inside of here, and assume a for triple bar intro to derive b. This seems kind of redundant, but it's necessary. And we have b already from line 4 for reiteration. And for number 7 and 8, we do the same thing. Assume b for intro to try to get a. We have a already from line 3, reiteration. So therefore in line 9 we can exit from these two with a triple bar b, and that's from lines 5 through 6 and 7 through 8, triple bar intro. So as you noticed with this little redundant redundant thing, we got a triple bar b, and we have a contradiction to that already. Line 10, tilde a triple bar b. From line 2, reiteration. Boom, contradiction. We can exit out of this little thing with tilde b. And we get tilde b from lines 4 through 10 tilde intro. And then we're going to have to, so thus we got a triple bar b. So we got this part. We're trying to get a triple bar b inside of here. That's the thing, is what we're after. We're trying to get a triple bar tilde b. That way we can get the other way around. And we're going to have to go ahead and assume tilde b for triple bar introduction to try to get A. And we don't have A sitting around, so again, we're going to have to assume tilde A for tilde elimination, trying to get a contradiction. And we're going to have to assume A inside of here for triple bar introduction to try to get B. And we want B, not tilde B, so we're going to have to assume tilde B for tilde elimination, get a contradiction. And we have a contradiction via that tilde A and that A. Maybe I shouldn't have picked this problem, but it really is neat. I think once it's all finished, it'll be neat. I think I'll go down to 20, and then I'll start 21 over here. Sorry if this is really small. I'll try and show it to you once I have everything finished. I'll try and show it to you more close when I have everything finished. Let's see here, tilde B. We have the contradiction, so we have A, and we have tilde A. And we have A, okay, we have A from line 14, reiteration. We have tilde A from line 13, reiteration. Boom, we have a contradiction. Therefore, we can X out of that with B, line 15 through 17, tilde elimination. We have B, therefore we have to prove the other side of it here. I'm going to go over here for this. You have to assume 19. You have to assume B because we have to prove the other side of the biconditional here. So we have to assume B for bar intro. And we're trying to derive A, and we have to assume tilde A because we don't have that. Assume for tilde elimination, derive the contradiction. And we have, you can see we have tilde B because this is the one that we're inside of. Let's see here. There's 1, 2, 3 inside here. Sorry, bookkeeping is kind of difficult here since it's much easier when I can just do it all the way down, but it's kind of off because of this long ass problem, which I probably shouldn't have picked. Let's see, 21. We have tilde B because that's the one that we're inside of from line 12. Reiteration. B because of line 19 reiteration, and we can exit out of that one with A from lines 20 through 22 total elimination, because we have that. I apologize for my bookkeeping. Let me see if I can do better here. Sorry. One, two, three. Okay. And thus from that we got A. And thus we can X out of this little thing here in number 24 with A triple bar B. And that's 14 through 18. And 19 through 23. Triple bar intro. And inside of here we have this, which is the contradiction of that. That's from line 2 reiteration, and thus we get that one. And then we can exit out of the whole thing here with number 26 with A, and that's from lines 13 through 25. Tilde elimination. And thus, with this bigger triple bar here, we can exit out of that with A triple bar tilde B. From, let's see here, from lines 3 through 26. Triple bar intro. Okay. And basically what this whole long ass thing was us taking this and getting that. And it looks really complicated, and I should not have picked this, and I apologize. But I'll try to explain it a little more once it's all finished. So we took this, got that, now we have to do the other way around, which I promise you is a lot more simple. Assume A triple bar tilde B, purposes of triple bar intro, trying to get tilde A triple bar B. And what we're going to do here is assume A triple bar B to get that for tilde induction. Assume for tilde intro, we get a contradiction. So we're going to try and get tilde B here. Because we're going to go ahead and assume B. This is a tilde intro. We have a contradiction. And we kind of have a contradiction because we have B, we have A from lines 29 and 30, bar elimination. And since we have A, we have tilde B. And that's from lines 28 and 31. Elimination. And we can go ahead and reiterate B in line 30. We got that one, therefore we can exit out of this. With tilde B from lines 30 through 33 tilde intro. So now we have tilde b, but then I'm going to try and go over here now, over this side. Now, let's see, 35. 2. And then we're going to assume tilde b for purposes of tilde elimination to derive a contradiction. And we have a contradiction because we have a as a result because of this here from lines 28 and 36 for our elimination, and through that we have b because of lines 29 and 37 for our elimination, and because of the subderivation that we're in, we have tilde b from line 35 reiteration. Boom, we have our contradiction, therefore we can exit out of this little thing with b from 35 through 38 tilde elimination, and we can exit out of the whole thing because we got a contradiction inside of this. We can exit out of the whole thing with tilde a bar b from lines 29 and 39 tilde introduction, and thus again what we did is we assumed this part and got that part, and we can exit out of the whole thing in line 40, 38, 40, can X out of this in line 41, yes, and with the thing that we actually wanted. It's triple bar, or tilde A, triple bar B, triple bar A, triple bar tilde B. Okay. Now, hopefully explain everything. What we first wanted was that, of course, we wanted that, and then we started with assuming the first part of it, assuming the first part of it, which is tilde H to 12 RB, and then hopefully, as you can see, we had to do a triple bar introduction inside of a triple bar introduction. Sorry if I'm doing bad cam work here. And we had to kind of do some things here to prove some of these things out to get contradictions and stuff like that. I guess it's kind of hard to explain all this in one big thing, but the whole point is that what you have to do is you have to assume one side to get the other side, and assume the other side to get the one side. There's a lot of different maneuvering that we had to do to finally get there. So, I'm sorry that I picked that up. I apologize for that. I should not have picked it. I should have picked something different, because that was a monster, so I'm sorry. If you think I messed something up or left something out, let me know below. If you have a question, if you want if you want more theorems, if you want more regular things like that, then do let me know in the comments below. I would do stuff like consistency, inconsistency, equivalence, validity, and stuff like that. But if you know how to do the problems themselves, and those are not a big issue. So I'll probably do a couple more videos before I move on to predicate logic, doing these kind of derivations. But let me know in the comments below anything you want to say. Thank you.